All right, everybody. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Tim Stahl, and I am a sales engineer here with Decisions. And this webinar today will be about machine learning models and how to apply them within Decisions. So we're going to focus really on a fictitious insurance company and how they can leverage standard web-based ML models within their workflows and rules. Before we get started, though, for those of you that are new to Decisions, we are a business process management software, and we help non-technical people to easily automate and optimize business processes, but without the need to code. On this slide are some of our current customers in different sectors, just to give you an idea of where Decisions fits. We're equal part rules engine and workflow, so there's a lot of different problems we can solve across different industries. So here are our lovely headshots today, so you can match a name with the face. We've had the pleasure of meeting many of you on webinars or over video calls in the past. So to get started, again, my name is Tim Saul. I am the Director of Pre-Sales Engineering here at Decisions. Been with the company about a year and a half, but was actually a customer in state government before that. And I'm also joined by Tyler. And Tyler, I'll let you introduce yourself.
Good afternoon, everyone. Good evening or good morning, wherever you are in the world. Thank you for joining us today. And I've been with Decisions a few months now, and I'm thoroughly enjoying it.
Awesome. As you can see on the bottom there, we have our LinkedIn profiles down there. We welcome any connections and questions through there, so please feel free to add us there and connect. Next thing to note, we'll go over some upcoming events. In this month, next week, we have a training. Our beginner and intermediate track will be going on. And one thing to point out, this is in British summer time. So we are a worldwide organization, and therefore we present our trainings and our events in multiple time zones throughout the year. So be sure to check that out if that time zone is appropriate for you. And that training is really for users that are new to that platform and haven't built anything before, at least the beginner part is. The attendees of this course, you'll learn and build a simple app as well as understand the primary functions in Decisions. Moving on to June, the 1st through the 3rd, we have a training, again, beginner and intermediate, but this one is on the East Coast of Eastern Standard Time in the US. So same kind of idea behind the training tracks. We also have coming up in June, we have our certification course. So this will be our fundamental certification. That is in Eastern Standard Time. And of course, fundamentals certifies that you are competent to build simple applications using the 5 designers within Decisions. And there's actually a follow-up quiz. So what happens is you go through the course, we train you on the product. If the requirements are met, you actually walk away with a certification. And then in June, we have our training track again, our beginner and intermediate, but this one will be on the West Coast. So this one's in Pacific time. So again, all of these events are on our website. You can always check them out at decisions.com/events, and all of the materials and things are available on our website as well. So our agenda today, we have a three-pronged approach here. The first, and this is going to be high level because this can be a very heady topic, but our agenda is going to start with what is machine learning. So again, from a high level, what even is that concept? And then we'll dive into some examples, use cases, and some ideas around ways that you could utilize machine learning within your organization. And then we'll follow it up, and I'll hand it over to Tyler, who will do a demonstration live in our product on utilizing machine learning algorithms and models within the Decisions platform and building forms and rules around those particular data elements. So to get started, at a high level, machine learning is a process that takes in a given set of input data or training and uses statistical analysis to determine the most likely outcome. So saying that another way, machine learning predicts an outcome based on an amount of training data provided to it. This is actually very similar to how humans learn. So say you were, looking at a picture of an insect that you've never seen before. The brain will begin by interpreting it at the highest level. Does it have wings? Is it large? Is it small? What color is it? Through more analysis, it may be determined that this insect is a small one. It has 2 orange, large wings compared to its body. as you continue narrowing down the sample, thinking through the different pieces of information you know about it and the similarities to other insects you may have seen previously, you may determine in the end that this insect might be a type of butterfly. And that's very similar to, and pretty much exactly how machine learning works. So there are many types of machine learning models out there and learning techniques available based on the analysis required to perform the function that you're looking at. And I'll just be honest, discussing all of those is outside of the scope of the webinar. But one method I will talk about, and really because it resonates and it's kind of an easier one to wrap your head around, is the artificial neural network. And that's what we see pictured here on the screen right now. So on this slide is a simplified representation of this type of model. So this model forms by passing training data into the algorithm. The machine processes for similarities and differences in the data. This is your middle layer here. And statistical analysis creates the score used to determine the best path available that leads to the answer. So for your given input, based on predetermined and pre-trained analyses, it determines which node it should go to next. And then based on a defined number of nodes that are within this middle section here, it will continue to iterate through and derive the best possible path and the best possible answer. So as more data moves through the model updates at each node the likelihood that its path will garner the correct answer. As you can imagine, these nodes can get very complex very, very quickly. And the example above is just a very simple example of what these look like. In practice, this middle layer is actually hidden from view. It's a hidden layer. A user typically interacts with this input layer and the output layer only. So, what are some use cases around here? Machine learning can be used in many areas and applications that involve predictive analysis and change over time. In each of these use cases, machine learning can help an organization perform more tasks automatically and efficiently and take the human out of the loop. In insurance, for example, maybe a company has a model that says if a person has, X number of accidents and a credit score in a certain range, and they've got a red sports car, that premium should be higher than another person with the same situation, but maybe with a black truck, maybe an F-150. That's something it's kind of contrived, but that's one of those things that as a human thinking about that, you have heard those types of scenarios. Whoever has that red sports car, they're more likely to get pulled over. Well, you come to those determinations using a very similar technique to what you can do with the machines. So, it's something that this ML model could be used to predict. So using these models, errors during maybe a medical diagnosis could be predicted and avoided based on, not only how a patient presents, but also their entire medical history. So that information is something a provider, may or may not have at the time of providing care, but a machine learning model that's plugged into that could iterate through all of that data and make a better predictive analysis possibly than the person standing in front of them. However, this could also be used simply as a backup, a check and a balance, a doctor or a provider providing care and a machine learning network providing another diagnosis or a similar diagnosis as well. So, in computer networks, for example, machine learning modeling is used for network switches. The way they identify the best, shortest path between 2 points. Should one switch fail in the route, the model can assist and the network can remain active by simply choosing another route. Fraud investigation, it's huge in fraud investigation. Depending on the type of maybe transactions that are occurring in certain locations at a certain time by certain customers, you can start to piece the data together and predict the possibility of fraud based on maybe a person's past transaction or credit history, maybe a person's or a store's history in how they operate as well. So all of that information is there and available for people to use, but a lot of times it's locked away in something that only a data scientist has access to. So another idea here as an example, suppose a company has a need to evaluate loan opportunities by considering the factors like a customer's earnings, their savings, and maybe their financial history. This can absolutely handle that. The information is taken from the past data on the loan, fed into this model, and a score spit out the other side. So, based on all of that data, all of that information you have about that particular customer, this could be something you could use within a workflow. So you have a customer, you're doing a loan origination, correct? You have a customer sign up and fill out an application for a loan, but using the past information that you know about them, you have a way that this algorithm could predict and give you an idea if of the risk of this loan and if it's something you would want to take on. Well, if you take that data and place it within a workflow, user logs into your system and fills out a form. The workflow runs that information through this algorithm, which processes it. And then based on the outcome, you could write a simple rule that says, based on the score that came back on here, maybe we automatically approve this transaction. If it has a confidence rating of 95 to 100% that this is a good idea, we let it go through. If it is below that, then we put the human in the loop where they can actually make a determination, maybe based on other factors. Some other examples out there of things that you've probably seen or interacted with. Netflix, for instance, machine learning is used in their recommendations engine. So it's predicting based on your past usage and your past history and your past viewing and what shows you like and how long you watch them and what times of day. It's able to predict other shows and other movies you might be interested in. Yelp uses it for all of their sorting, their tagging, their categorizing of all the photos that you upload on the particular reviews that you have. Of course, we've all seen the Google self-driving cars stuff out there. That's another way that it can predict as it's moving through and taking in enormous amounts of data about its surroundings from, what is near me, what's in proximity, what is the current speed I'm traveling at. All of those factors it can use to predict, is the traffic slowing down in front of me and I need to take action on that. Is there a roadblock up ahead and I need to reroute? Another one that's fascinating is there's a company that's using machine learning, this Kensai, to do patient sickness predictions and remote patient monitoring. So they're remotely monitoring chronic patients with predictive risk identification of ER visits and risk of readmission. So they're able to really utilize these models to improve patient experience and care outcomes. And again, all of this is usually something that's in a very complicated box that only developers and data scientists have access to. However, using our built-in workflow tool and the API and REST integrations that we have, you're able to bring the power of these algorithms into your workflow very easily, and they simply become a step in the toolbox that you can drag out and use. So, machine learning models can be used in decisions again by adding them as steps to a flow of the process. So in this instance, once we've pulled some data from a system, as you can see here, we're running that data through an ML model, and that's returning a set of results. So when we set these up within our platform, this is exactly what it looks like. It is literally one step in the workflow. The results are then run through some rules, and we determine a confidence score for each record. If it's above 80%, then we generate a risk calculation based on that return. So in this case, the model is providing initial processing to the data, which is then used to drive rules and automation in the system. So using the power of the Decisions no code platform, we're easily able to integrate with extremely complex models, but with ease. The work of developing the model could be handled by an expert or data scientist, but the business user now has the ability to drag and drop a simple step into their workflow and gain this functionality. So with that being said, I'd like to go ahead and turn this over to Tyler. So what we're going to be doing today is using some off-the-shelf ML models from Google. We're going to show how easy it is to integrate these models into a real-world application. So with that, I will stop sharing and turn it over to Tyler.
Thank you, Tim. Tim, can you confirm you see my screen and seeing the Orange Decision Studio at the top?
Looks great.
Thank you, sir. So as Tim described today, we're going to walk you through a process where we're actually using two different machine learning modules, one from Azure Microsoft and one from Google. So we're going to take this learning modules to use them for a insurance risk score for a car. So let me simply click off my flow. As you can see, this is a very simple flow that just has a form, which we're going to debug. Now, when I debug this form, you're going to see the form requires some inputs. Tell us about the car. Now, what you'll notice is, please pay attention on the right-hand side, my SA premium is $600. Now, as I take inputs into the left-hand side, the estimated premium will change, and also we'll be calling out to both those machine learning tools on Azure and on Google Vision to be able to classify things and find a risk score on an actual car. So as you look at my car model, I have all my cars. If I select, let's say, Cadillac, I'm given Cadillac models. If I select a Toyota, I'm given Toyota models because Decisions is data aware. So I'm going to pick a Toyota Camry, and of course, I have an old Toyota Camry. Now, as you can see, once I put my year and model of the car in, it tells me, okay, this is the stolen risk car score. It's a 5.31 because nobody really wants to steal a 2001 Toyota Camry. You're not going
And is that like we're rolling the dice on this?
Yes. Yes. Thanks for the good catch on the icon. Yes, we're rolling the dice on this. So out of a score of 100, this is only a 5.31 because the chance of a 2001 Toyota Camry getting stolen nowadays is very, very slim. Now, as I input more data into this thing, you'll see the estimated premium automatically changes. And then once I get down to my image, I will be able to call it to Google Vision and be able to tell, okay, I'm going to upload a car photo, and I'm going to pick this 1999 Toyota Camry. So we're going to see if this machine learning tool can say, this old Camry, which right here is not white, can it tell it is not? And you can see we got a 14% image accuracy. Well, that's due to the fact that we've inputted into this that it's a Toyota Camry from 2001 and it's white. And of course, as you can see, this isn't white. This is, of course, you can see right here, it's 2097 to 99. So you can see right here, we're getting a 14%. It can recognize it's a car, it can recognize it's a Camry, but it doesn't think it's the correct model and color, of course. So by using these machine learning tools to decisions, we can then act upon them in decision to be able to do things. Okay, should we approve this one? This is a low risk score. We think it's not. We think it's not. Do we go ahead and approve this insurance claim or this insurance policy, or do we not? So you can see very easily right here, we can actually take these machine learning tools and be able to implement decisions into a form or flow and be able to act upon them.
So in this case, we could say that this would help us automate the process, take the human out of the loop in certain circumstances, and really, again, leverage the power of these off-the-shelf tools, but in our standard workflow.
Absolutely. And what we've done also is run this through a rule set that allows you to take these inputs from the machine learning tools of the risk score and the image accuracy, then produce that $290 premium. Because then you can base your score based on the machine learning risk tolerance you have in your organization. Like Tim said, we can have an 80-20 rule where 80% is approved by machine learning, but then you have 20% which is approved by an individual who might want to overview it, because you might want to get this one assigned a task or assignment and decisions and say, I really want a better picture of this car before I approve this, so that person then can reach out to the insurance supplier.
So now, as a question, these forms, we want to point out, these are actually built-in forms in decisions. So these are, using our standard drag and drop form designer, you're able to create things that look just like this, and then plug in these various pieces to really, enhance that user experience and ensure that these models are being used effectively.
So now I'm going to simply show you in debugger how we're actually doing this. So I'm going to my image conference data flow. And as you can see here, it turned a true image. And I'm able to see my check confidence data flow down here at the bottom. So as you can see here, I'm actually passing in the bytes, passing in the Google Vision detection. And we'll show you here a little bit later how we're actually created this Google Vision label detection step. I deserialize the JSON, and then I check through each line of the JSON. As you can see here, it contains quite a bit of data coming back from Google Vision of, okay, you can see automotive right side, it sees a parking lot, it sees a tire, it sees it's a car, and go on down the list and say, okay, for each one of these items that Google Vision provides back or machine learning provides back, we're then able to take those inputs, run a rule on them and say, okay, is this a car? Is this a Toyota Camry? All of that for each one of those inputs, and then create a confidence score based on color, based on different variables through the machine learning and decisions.
And also, what I was talking about, the scores that the algorithms are spitting out. If you see, even on the middle there, where it says description as a car, and it has that score there, that's it saying it's 97% sure that that's a car. So when we start talking about the confidence scores that these models have, this is the actual data that comes back from, in this case, Google.
Absolutely. And we can plug in any machine learning tool you might have into this. So you can see very quickly and easy how easy it is to input the machine learning tool into decisions and be able to use it in a workflow situation. So now you might ask a question, how do we actually create this Google Vision step? So now I'm going to go simply in to show you how that works. So with inside decisions, we create different types of integrations. So as you see here, I have a machine learning integration, and I also have my Google Vision integration. So if I can simply edit my Google Vision one to show you how this one has worked. So this one, service name and my service URL. Now, as you can see, we can pass different parameters into the service URL. You see it's a post message in JSON, and then right here at the very bottom, it shows what data to send. And by having this data to send, it's actually inputs, which I'll show you here on the flow here in a second. That's actually, we can select from the flow, select from the workflow or a form or external system to be able to then send to Google Vision for machine learning. Now let me go show you how that actually works in the flow. So if I look at my Google Vision label flow, same flow I showed you earlier, a little different session. As you can see right here's my flow, my image contents, I pull into there and be able to actually do the machine learning tool right here by actually taking my image, converting it to 64-bit string so that it can actually be passed through an API. So as you can see right here, if I go down here my integrations, it is a very simple step. I'm able just to, excuse me, wrong button. It's a very simple step. I'm able to drag and drop my step over here, and there's my detection level 2, be able to add it right into my workflow with by adding my key and my image.
And that's really, while we're on here, that's really, again, when we start talking about complex things like machine learning, this is where we can really shine. You can have folks that are comfortable and familiar with this, work with them to set these up or provide the connections to them. But then you can have this where it's simply one step. This is a lot easier to train someone on how to use. You can simply pull this step out. You can categorize them like we have them on the left there in the steps toolbox. But now, as Tyler showed, you can just drag that out, plop it in your workflow, and connect it up and use it as you need.
And now I want to show you how we actually use an Azure machine learning. Now with Azure, the different machine learning tool we have here, and as you see, I created the service. It's called the service URL. Now we can pass authentication here also. So if you need a header, some of the authentication here also. Both inside of Azure Machine Learning, I have my risk model score here. And with this method I pull in my post, I'm actually deserializing from data types. So within decisions, so you don't have to deal with data types or JSON, you can actually serialize that data into a data set in decision, data structure and decisions. That allows you to be able to quickly and easily being able to put data into the JSON to be able to call it to machine learning, and also pull data from machine learning. So you see my data output is Azure result. So pull data from Azure, put it from my JSON, put it right into decision to be able to use that in our workflow, as you saw earlier, to get the risk score of 5.31. So there's two different types of operations we have in integrations. You can either deserialize it through a step, or you can actually have the actual REST integration method deserialize it for you. So it makes it very, very easy to be able to do machine learning modules and call out to them without having to actually create complex code or create different models inside decisions. You just simply call out and you can use those machine learning tools in throughout your organization.
Yeah, so as you pointed out on that, it's really about how do we take something very complex and complicated, and create it in such a way that folks can wrap their head around it, use it, or even kind of have it as a black box. So there's this very complex thing I need to use that really helps me automate my process. I'm pushing in a bunch of data. Some complicated things are running in that black box, and they're spitting out a result that then I can use in my real world situation to drive my decisions in my workflows. And anything we can do is we're setting these steps up to make that easier. Like he showed, creating that data type so that way it's something they just have to pass it in. They don't have to understand how it works. You don't have to have all these extra steps. It just becomes one step that they interact with. So it's something very approachable for folks if they've not been exposed to machine learning before.
And as you see right here, my very simple, just drag and drop step with the risk model. And I pass in my data array that came in of color, make, and model, and very easily pass that in and be able to actually execute the step through my risk model. And I was able to do that by simply creating an integration, and then just like Tim said, to make it easy, just drag and drop, machine learning, able to drag and drop that step on here, produce that data, and be able to call it out to machine learning. This allows you to use two very powerful tools in machine learning decisions to be able to integrate them very simply and be able to use this in your business model, your organization, to be able to produce a lot of different data sets and be able to work using your workflows. So we have covered about 30 minutes. Is there any questions in the chat, Tim, that we have?
No, but it's a very what we really wanted to focus on today was simply showing kind of a teaser, right? There are a lot of machine learning or algorithms that are out there and a lot of ways to connect to them. Some of the big ones out there, like even using TensorFlow or using Python or using various ones that Google provides, I guess like TensorFlow, can be very complex and complicated to set up. But our goal was to show you that we can take that complicated method and place it in a way that a user can react with it. We did have one question come up in the chat that says, are the REST APIs we're showing publicly available, or is it something we have to purchase? And that's a very good question. The Google Vision One and the Azure Machine Learning they are something you have to pay those two companies for. We use them internally for a lot of our demonstration purposes. And for some of our attendees or some of our folks who are looking to embed those and looking to have them as part of their platform, but you're right. These ones are ones you would have to talk with Google or talk with Azure for to set up that account. Now, there are other ones out there that you could also use and consume that are free. They're open source things, that you could write in Python, for example. And we have a Python module built into the platform that can actually interact with those as well. So if you have models that are in that, you can pass data in, you can pull data back out. Again, they show up as one step, similar to what we just showed here. But that is available to you as well in the platform. And that being said, I'll we do want to go ahead and open it up for some questions. If there are any others out there, feel free to please put them in the chat, and we'll be more than happy to answer those as they come up. Give it just a minute here.
And yes, $25,000 for a 20-year-old car is a little exaggerated, but I want to have a little fun. It's a limited edition Toyota Camry.
And I did have another question up. So it says Decisions doesn't have model training baked in. It's all leveraging other products. And you are correct. We know where we excel, and that's in the workflow and rules and business engine piece of the platform. We, in the case of machine learning, there are so many companies out there that specialize in that we, took the idea and took the step of integrating and making it easy to integrate with those products. I did see another question came up. It's very interesting, very practical, but this particular client cannot use any cloud resources. Also, those are just web calls. I trained on my own several models using TensorFlow and Keras. Is it possible to use those? Again, if we have the ability to connect to those, then absolutely. Whether that's over, a web call. Again, I noticed you said it can't be a cloud resource, but if you have it, maybe an on-premise call, you absolutely could. If you have a way to connect to it, we absolutely can. And again, if we can connect to it via another stack, such as Python, or even over C# using our SDK, then we absolutely could use those models directly in decisions. And I did see one other, like with the other elements in the workflow, I suppose you could chain outputs from one model as inputs to the other. And you're absolutely right. That is exactly the way our system works. So yeah, that's a great idea. So just like with our workflows, just like with our rules, how you can chain them together, you could absolutely take the output of one model, process it and pull the data out that you need and use that as input to another to further enhance your particular workflow. I did have one other question come in, is asking which version of Decisions has the REST API, connecting to the machine learning model via REST API, as we showed. So we were using Decision 7, but that is something that's been available in the product for quite a long time. So if you're still on 6, or I believe even in 5, you can use our REST integration service to connect to those particular ML models. Great questions. Okay. What would I search for when looking online for ML models or other APIs? Yeah, so there are, if you go out there and look for, and I know this is going to sound cheesy, but if you simply search for best ML model, a lot of them come up. But there are things out there. Again, we've mentioned a few of them. So one of them is Azure Machine Learning. You do have Amazon has its flavor of it as well, and using those company names with ML or machine learning after them will give you quite a few results that you can go after. Again, if you look for ML and Python, you'll get a whole lot of other results that'll come back from there. But again, another one of the big ones in the market is TensorFlow, and that is, I'll actually type that in the chat, TensorFlow there, so that way you can see what I had typed. But that's another one of the major algorithms out there. Okay, everybody. Well, we really appreciate all the attendance today and the questions. It was great questions, and for a very what can be a very involved topic. So, if there aren't any further, Tyler and I both thank you all for your attendance. And from Chesapeake, Virginia, we are signing off. Everybody have a wonderful day.